Okay. Yeah. Hi everyone. So we are happily inviting you for another system design series use cases, which is in this session we are going to discuss about how the chat application is generally it's functioning. It's chat application like which are WhatsApp, Messenger, Telegram, whatever the state chat application we have, how it's generally it's functioning. If you want to build that, what are the things we have to do it? So that is um, the core agenda we are going to discuss about. Here we are going to look into it. What is the functional requirements? What are the functional requirements we need? And then what are the non-functional requirements we have to consider? On what is the estimations we can do it like for a storage and then the capacity or the back of the envelope estimations we are going to do it. And then what is the database designs that we are going to do it. And then what are the tables and each table, what are the fields it has, everything we are going to discuss about that. And then we are going to discuss about API design as well. So what are the APIs are leastly we need to start the application. Okay, build the application and what are the key issues. And then finally we will discuss about high level architecture of the chat application. Okay. So the features wise, let's talk about functional requirement. So user can do one-on-one messaging. They can do it, and group messagings also they can do it, and real-time message delivery status they can get it, which is like whether offline or online users. And then media support. They can upload image, videos, or documents. Also, they can send share it, and then message the status we can get it like whether it's a read or delivery that is not able to send it, this is status they should get it. And then the end-to-end encryption that is really needed. Okay, so messages it will not be uh, get by any in between or intermediate persons. Okay, so the encryption is really important for a data privacy. And then the message history we have to keep it. So if it's a optional one, they don't want to, they can delete it. And then the notification, whether it's a push or a email notification. And then profile preference, and then presence, whether it's they are on online or offline, that's details also we can uh, these are the functional requirements, okay, for a chat application. And what are the non-functional requirements? The system should be highly available and low latency. Okay, it should be horizontally scalable as well. Okay, so it can handle millions of users at the same time. So consistency for messaging. So eventual for present, strong for message delivery. So which is eventual, we can expect some delay uh, for our user presence. Okay, but message delivery, it should be very very strong consistency. Okay, when they send the message, it immediately it should be seen by it's sent to the end user. Okay, so that is strong consistency, we need that. And security wise, highly encrypted and authenticated ASN system. We need that, and fault tolerance and reliability and complaints. We should follow GDPR. Uh, the complaints we have to follow it for storing user data, and then rate limiting for, and then abuse detections, the prevention, fraud detection, prevention, that also we need that. Okay, so these are the non-functional requirements we should keep. And then what is the back of the envelope? Okay, so how much we can estimate how many users they are going to use our service. Okay, so we can expect 100 million active users per day. Let's take about any chat service. It's a WhatsApp. Okay, we can say 100 million daily active users in the global level. We can expect it. Average of 50 messages per day per user. They can do it, which is like 5 billion messages per day. We can expect it for 100 million users. 5 billion messages we can expect it. Okay, so 300 million messages per month, right? And then message size, we can averagely we can calculate 1 KB, which is equal to 5 TB of data, 5 TB per day as a raw data. Okay, the messages we have to consider. So and then media, 10% users, They can send them any media related contents, which is like average 5 MB per day, which is like a 550 TB per day. We can estimate it. Okay. And then peak query per second, we can expect 100 K messages they can read per second. Okay. So in the global level. Okay. So this is the estimations of user level, and then the storage, and then wow, exact storage how much. The text messages we can expect 1 petabytes of storage per year. We can expect it. Media storages like images or videos, we can expect 15 to 20 petabytes of data per year. High dependent on the usages, how they are using it. Okay. So this is the basic assumption for estimating the storage and the users. Okay, which they are going to use it in our application. Then what is the database design? What are the tables we need? So we need a user table. It has user ID, name, phone, profile photo, status, and then when they are last seen. Okay. So we can keep two different tables, one SQL for metadata, no SQL for messagings. So we can use hybrid approach. We can follow it. And conversation table, which is like the conversation we can keep one to one or a group conversation. The conversation ID we can follow it, whether it's a group or not. What is a group name? What are their participants? So that we can keep it. And then messages, the NoSQL table we can use it. The message ID, what is the conversation ID, and then who is the sender, what is the content type, what is the content, and then that like the timestamp, what is the delivery status, everything we can keep it. Okay. So and then the message status, so message ID, user ID, status, timestamp, optional for tracking per user read, how many what are the users they read, that's also we can keep it. Okay. So, which is like, for example, in the group, so the particular message is read by how many people, like what are the people they read the message. So that the message info, we can get it like this. What is the message ID, which user, whether they read or receives, the timestamp when. So these are the table level structures we need that. And then well, let's talk about the API design. What are the minimal level of APIs we need to build the MVP application. Okay. So we need a register and login API for auth module. Okay. User can register and then they can log in it. And then messaging side, a message send, and the messages conversation get method. In message, then they can send the message. Okay. And then the conversation, they can fetch the history or the paginess and things, we can do it. In the entire conversation message, we can get it. And then the WebSockets we need that will send the messages in real time messages, they can do that. And then in groups also we can create it. In the groups, create group, add group, remove, that we can do it. And media upload, so any files they want to upload, they can do it. Okay. So these are the minimal level of APIs we need. And what are the key issues and solutions is that scalability is the one of the issue. Okay. So the what is the solution? It would be maintain stateless microservices and partition the message storage based on their conversation ID. So this is the one of the way to scale the system. Okay. So real-time delivery, message delivery, we can use WebSockets or MQTT based socket infrastructure, the Kafka for fan out architecture. Okay. So and then offline delivery is one of the things. Store bending messages in DB or Redis, push when they are reconnecting it. Okay. So message ordering. So use timestamp plus vector clack, or you can use Snowflake ID to message, keep the message order. And then delivery read status. What is how we can get that? Track the status per message per user, or use push notification receipts. Okay. So handling media. So upload the data to S3 and store the signed URL in the message. So in your database, we can store it. End-to-end encryption, client-side encryption using E2 end-to-end encryption. Example, signal protocols that we can follow it. Client-side encryption, we can follow it. Abuse and spam preventions, rate limiting, and content filtering and user blocking things we can follow it. Okay, message deletion and privacy, soft or hard delete. Okay, and then TTL's time to live and GDPR complaint support that we can do it. And scaling sockets, use load balanced WebSockets via sticky sessions. Okay, so that will help us to scale the socket connections, concurrent connections, and load balanced circuit connection we can do it, and redis for pops up messages. These are the key uses and these are the solutions we can do that. Okay, now let's move to the high level architecture. Yeah, so here we can see whether it's a web app or mobile app, everything we can. Then we have a front end service. Okay, so this is the user interface service we can, public interface service we can consider. It has DNS, domain name server, and a service, and then WebSockets or a REST API. We have a WebSocket, it will help us to send some real-time messages. Okay, REST API is gateway, it will help us to perform some other operations, whether it's a group creation or a user registrations, that things we can use it. API gateway, and then we need a validations, authentication, we need that. If the particular API call is authorized user, then only they it will be sent it to the next service, otherwise it will throw the error. Okay, the authentication validations we need that. Then we have a notification service. Okay, we have a various services we have. Okay, so let's go one by one. So we can see notification service here. And then in REST API service, we can see the user management. It will help to keep users and group services. Okay. And the notification service we have, it will process the notifications and then push the notification to the users. Okay. The push notification is coming here at mobile app. Okay. So here we have a mobile app. So it will connect it with the DNS, and then yeah, so this is how it will come, request API to user management service or messaging service. So a request will come here. Or the WebSocket messages. Also, we have another group of service, message processing. Okay, it will we have a separate computations for maintaining the connections between various WebSockets, various client systems, and then we have a messaging service. Okay, so the connection manager is can communicate it with the messaging service, and then we have a message queue also, we have to keep the order of the messages we have. Okay, and then for data persistence, so we have a separate database layer. So we are using various databases, we are using it for user data or user group data, we are using SQL, and then message storage we are using NoSQL database, DynamoDB we are using it, and for sessions and presence and catching the data we are using Redis, the cache system we are using it. For a media files, we can use S3 bucket. Okay, so message queue for storing the messages in the order. Okay, and message deliverable as well. Then the security and permissions as well. So make this connections secured connection. So the data between the connection between client to server, the data transmission it should be secured. Okay, in the fly the data it should be secured, so we can use SSL TLS certifications, we can use it. Okay, so and then we have a monitoring service as well that will help us to monitor our the entire system, so we can use Prometheus, Grafana dashboard, we can use it, and even Bridge for collecting the logs, everything we can use it. So this is all about the chat application, what are the components, what are the services we need that, and how it interact. So we need a front end service, it has DNS, WebSocket, API gateway, authentications. Notification service, it will help us to send the notification to users. And then we have the user management service to keep users and groups related data. Database layer, we have a three different tables, like a three different categories of database we are using it. You said structured data we are using NoSQL, unstructured data which is message data we can use structured data we are using SQL, and unstructured data we are using NoSQL. And message processing service we have a connection manager which is maintaining the WebSocket connections, and the message service it will send the messages to the specific user. And then like a message queue also we need that to maintain the order. And then S3 for media file storage and monitoring service also we have. So this is all about the chat application development. Okay, I hope this session is useful. Yeah, we will see you in upcoming session with new use cases. Yeah. Okay, yeah. Thank you. Thanks everyone.